Hey guys, welcome to lesson 6. This is actually lesson 6. It says lesson 5, so please fix that. Lesson 6, conditional probability. Pause the video and try the do now. The do now says, using the Venn diagram below, what is the probability of selecting a student who is a senior and is in math? Again, please circle your operators. Your operators are and or so far. So here let's kind of evaluate or analyze our Venn diagram. So this part is and. This means that there are 40 seniors who are taking math, right? This circle, I'm going to circle in blue. This is a full circle, which is for seniors. So there are actually not 210, but there are 250 seniors, total of 250 seniors. Students who are taking math are 150. So the rest could be 110, could be anything. They could be juniors, your sophomores, anyone, right? And 840 students in the school are not seniors, and neither are they taking math. So that's how we read a Venn diagram. But if we want to find out how many seniors are in math, so that would be your intersection, which happens to be 40, right? So probability of senior and math is what? 40 out of the total sample space. What's my sample space? How do I determine my sample space from these numbers? So you just basically add up all the numbers, because that's your universal set, right? So these are people who are not taking are not seniors or taking math. So 840 plus 210 plus 40 plus 110, which would be 1200, right? You can simplify it to 4 over 120, or 4 goes into 120, 3 times 1 over 30. You can choose to write it as a decimal, a fraction, whatever you want, okay? Unless the question is being very specific. Okay, so please be very careful of that. Now, what is the probability that a student is a senior who is taking math? So it's telling us, look at the seniors, how many seniors are taking math. So if I look at seniors, how many seniors are there? Out of 250, how many are taking math? Only 40. So the probability of senior who's taking math, I'm just going to write that because I've not introduced the notation. Math. So out of all the seniors, there are total of 250 seniors, right? Because the circle of seniors adds up to 250. How many are they taking math? Only 40. Okay. So how does that roll into a lesson today? Conditional probability. Conditional probability has to do with conditions given to you that an event has happened first, and then we're following up what's happening next. So let's read through it. The conditional probability of an event B in relation to event A is the probability that event B will occur given the knowledge that the event A has already occurred. Okay, the probability changes when you have partial information. This affected probability is called conditional probability. Okay, first of all, let's talk about the notation. This is read as probability of A given B. I'm going to write that out. Probability of A given, that line is read as given B. Okay, oh, it's written here too. I didn't realize that. Okay, so how do I read it? Probability of A given B. This is the rule. And A and B could be replaced with anything. Doesn't matter. How I want you to memorize it is the intersection of the two over the given. That's what you are, probability of given. The probability of the intersection over the probability of given. That is how you're going to remember it. And it's really a very straightforward concept, but don't try to confuse. You read the question, identify what is given, and that's it. This formula worked for our do now. Notice that our answers was the intersection of the seniors and the math over the total number of seniors, which we kind of did that, right? So again, I wrote the rule here. It doesn't matter. How do I read? Here, A given B. B is the given one. The one letter that's written after is the given. We always refer that, okay? So Sean's team has a baseball game tomorrow. He pitches 50% of the game. So again, your probability is between 0 and 1 or 0 and 100%. It can be written as a decimal, as a fraction, as a percent, okay? But if it's written as a percent, you want to change it into a decimal. So it'll be what? 0.5. So probability of him pitching is 0.5. Let's call P for pitching. There is a 40% chance of rain during the game tomorrow. So let's write probability of rain is 40%, which is 0.4. The probability that Sean pitches and it rains is 20%. So probability he's going to pitch and it's raining is 20%, which is same thing as 0.2. What is the probability that it rains given Sean pitches to the nearest tenth of a percent? So again, we're going to round our answer to the one decimal place. Okay, and my final answer is going to be percent. So that's something we'll talk about later, but right now look here what is given. We're going to set up the rule. So it's asking me what's the probability that it rains, given. So for given we put that line. You don't have to draw it that big, but Sean pitches. Probability that it rains, it's going to rain given Sean pitches. So my given is pitching, right? So what did I say? It's intersection. So the intersection of the two, probability of rain, and he's going to pitch over the probability of given. What was my given? Pitching. So what's the probability of rain and pitching, which is 0.4. Oh, rain and pitching is 0.2, sorry. 0.2 over probability of he'll pitch is 0.5. So 0.2 divided by 0.5 is basically 2/5 or 0.4, which is same thing as 40%. So it's set to one decimal place to the nearest tenth of a percent. So 40%, right? So that's basically it. Again, I will highlight the fact that, guys, you have to make sure that you understand this rule very well. You know how to set it up. Because if you know how to set it up, then everything will come easy. Okay, let's try another one. Andrea is a very good student. The probability that she studies and passes her math. Again, very important to read the questions carefully. So let's say S is for studying. If you want to underline and write S, and passes math, let's write M. Probability she studies and passes her math test is 17 out of 20. Probability, if the probability that Andrea studies is 15 out of 16, so if she studies is 15 out of 16, find the probability that Andrea passes her math test given that she studied. So she passes her math test given she studied, right? Which is what? The intersection of the two, math test and studying, over the probability of the given. My given was what? Studied. It really will say the word given, or sometimes it does use if. It's very rare, but for most part it will say given, so you know it's conditional probability. Okay, so it would be what? 17 over 20 divided by 15 over 16. You can actually use alpha, alpha y equals yes in the calculator, do complex fraction, or you should know how to simplify it. It's keep change flips, 17 over 20, division changes to multiplication, and flip this fraction. So it'll be what? 16 over 15. You can simplify that, and it simplifies to actually 68 over 75, which is same thing as 91%, 0.91 or 91%. It didn't really tell me what to, so even 68 over 75 would have been a acceptable answer. Okay. Number one, the guidance department has reported that of all this, of the senior class, 2.4%, I'm going to start converting them into decimals, which is 0.024, are members of the theater club. So let's write this down. Probability they're a member of a theater is 0.024. They're enrolled, 9.4% are enrolled in stats. So probability they're enrolled in stats is 0.094, right? And then 5% are enrolled in theater and stats, which is 0.05. Determine the probability of T given S. Determine the probability of that they're enrolled in theater given they are in stat class to the nearest hundredth. 100 has 2 zeros, right? Of a percent. So what would this be? Probability of theater and stats over probability of stats. So what is probability of theater and stats? Theater and stats is 0.05 over stats is 0.094. Put that in the calculator, you get 0.53191, which is same thing as 53.19%, right? You're just multiplying by 100 or moving the 2 decimal over. Again, this information, if you are like, oh, why did I need this information? If it's given to you and it's not being used, don't panic. It was not to be. That's why you have to determine what has to be used and what has to be left out, okay? So let's do one more. I'll do 2 more, and then you can finish the rest. The probability that Sue will go to Mexico in the winter and to France in summer is 40%. So she's traveling to France for F, and summer is 0.4. The probability that she will go to Mexico in the winter is 0.6. The probability she'll go to Mexico is 0.6. Find the probability that she will go to France this summer given. So there you go, given. Probability she'll go to France given she went to Mexico. So again, probability of France and Mexico over the given. The intersection over the given, probability of Mexico, which we kind of know, probability of France and Mexico. I don't know why I wrote S. This was M, sorry about that. I think I confused myself with summer. Is 0.4 over 0.6, which is 2/3, and which is same thing as 0.667 or 66. It didn't tell me to round to any number. So any of these answers will be acceptable. Okay, one last one. A penny and nickel are tossed. Okay, if you toss a coin, what's the sample space? It's 2. Either you get a heads or tails, right? A penny and a nickel is tossed. So what's the probability of tossing a penny? 1/2. What's the probability of tossing a nickel? 1/2. And these are independent events because the probability of one is not going to affect the probability of the other one. So a few things to keep in mind here. Find the probability that a penny shows heads given. So probability penny shows heads. I'm going to just write penny heads given nickel shows heads, right? So it'll be what? Probability of penny heads and nickel heads over probability of given nickel head. So probability of penny, how many times penny can show heads? 1 out of 2. And we're going to multiply here the intersection, right? Times the probability of our nickel head would be 1/2, 2. Also, and what's the probability of a nickel head given? It'll be 1/2. So 1/2 times 1/2, it's just 1/2 or 50%. Okay? So guys, please finish up the remaining packet. And if you have any questions on any of this, please feel free to reach out.